All right, good day everybody, and today we're continuing our series on calculus. In the previous video, we would have addressed the power rule, and we specifically looked at how to use the power rule when differentiating a constant, a rational, and also a verb. Today we're going to move on to the product rule under calculus still. And our objective for today is basically to differentiate using the product rule. And maybe I should have also added here, we have to be able to also identify when the product rule is applicable. That's key, that's very important, and it's one of the things that a lot of students struggle with because yes, even though they know to perform the rules, sometimes they do not know when to perform it, and that's very key. So we're going to be discussing all that in today's video. So here is in a nutshell, here is the product rule. And as the product rule implies, product simply means that you are multiplying. A product is usually the result of multiplication, right? So if we have f of x is equal to, for example, f of x, small f of x here, times g of x, which is a function multiplied by another function, the product rule simply states is that we differentiate the first and we multiply it by the second, and we add that to the differentiation of the second plus the first. And the beauty about the product rule is that because multiplication and addition are commutative, it does not matter really and truly which one you choose to find a derivative first, then multiply by the other one. The fact is that you will still end up with the same answer. And that is because of the commutative law, which tells that regardless of how you switch the positions, you will end up with the same answer. 2 plus 3, for example, if I might just write it up here, for instance, 3 plus 2 or 2 plus 3, same thing, is actually the same as 3 plus 2. And this is what the commutative law states. The answer would not be interfered. Here we will get 5, and over here we will also get 5. So I know sometimes we hurt our head as to which one we should differentiate first and which one we should leave like that. It doesn't matter. Here we have a second example showing if we have f of x as a function and we have the first and the second. It simply tells us there, we differentiate the first and we multiply by the second as is, plus then we add the second one, we differentiate, and then we multiply that by the first function as is. So this is two generic ways of showing it. I'll just make my input here now, and I generally like to look at it this way. So if I have, for example, f of x is a given function, and let's say I have a multiplied by b. So this is assume that a is a function and assume that b is a function. So if I have to find a prime of x, which is the first derivative of x, how I like to see it personally, again assuming that a and b are functions, I like to see it like this. You have a and you're multiplying that by the first derivative of b. So, and that's the function b. And then you add in that to b, and again, because of the commutative law, this is possible, b times the first derivative of a. Basically, that's what we do. So we have a times b prime, and then we have plus b as it is times a prime. So you leave one as it is, so you keep one function as it is, and then you multiply by the derivative of the second one, and then you add that by whichever one you found the derivative of the first time, you leave it as it is in the second half of your sum of addition, and you multiply that by the first derivative of the other one. And again, it just looks complicated, but as we get into the example, you will see how easy it actually is. So let's get into some practice time here now. That was basically an explanation of the rules. Now let's see if we could do it practically. So here we have 3 questions, 3 functions, of course. And as I said, it is key that you firstly be able to identify when to use the product rule. And in this video, well, I guess it's easy to know in this video because we know it's all about the product rule. But what you really have to pay attention to is the fact that a function is being multiplied by another function. And that is how we know that the product rule is applicable. So here we have 2x to the 4th being multiplied by 2x plus x cubed. And we know that these two are functions. So 2x to the 4th is a function and 7x plus x to the 3rd is a function. And in case you might be wondering, how do we know when something is a function? Then we just have to go back to our algebra. And remember, when we do algebra, we identify a function as anything that gives you an output to the y value. So x has one and only one output for the y value. So you could think of it like that. So if it's not a function, then of course it will be more than likely a relation. And in a relation, as we know, I don't want to go too much into the algebra of it, but we know that a relation couldn't a relation doesn't necessarily have to be a function, but all functions are relations, or something to that essence. I could be mixing it up here now. But the key thing to know about a function is that it has a relationship with y. And that's how you know you have a function. So for example, if I have 3 multiply into this other fraction, this other function here, then we know that this is not product rule, because 3 just like this is not a function. The 3 as it is here is just giving us a value, and that will just simply tell us maybe that y is equal to 3, but that is not a function. So how do we know that the product rule is plausible or legible or possible? Simple. A function multiplied by a function. And these 3 examples here demonstrate that. So let's go now and solve them. Again, as I said earlier, you can pause your video here and attempt them, and then after go through and see if we get the same thing. Again, you could take the time to subscribe and like this video as we go ahead to solve this. So here we have y is equal to 2x to the 4th multiplied by 7x plus x cubed. And again, product rule, remember the rule. So we have now y prime will now be equal to, I keep the first function as it is. So I will keep the 2x to the 4th as it is. So I have 2x to the 4th. I ain't changing nothing there. And then I find the first derivative of the next function. The first derivative of 7x plus x cubed, applying the product rule here, not the product rule, the power rule, I will end up with 7 plus, remember the product rule, 7 plus 3x squared. Remember, the 3 goes in front, and then I take away 1. Simple power rule. We did discuss this in a previous video. You can just go back and look at it. Right, and this is the end of the first part, and then we add. So plus, and again, now I keep the second function as it is. So I have 7x plus x cubed, 7x plus x cubed, and I multiply that now by the derivative of the first function, and that will give me here now 8x cubed. And again, just recalling the rule, the 4 goes in front and I take away 1. So the 4 times the 2, that gives me 8, and when I take away 1 from the 4, that gives me 3. That's just the power rule there. And again, once I do this, I am finished with the differentiation. From here now is just a game of algebra and simplification. So let's see how far I could simplify this. Sometimes after I do this, this is as far as you go, but sometimes you could play around a little and see how far you could go in terms of breaking down. And in this case, we could go a little further. So here I'm multiplying the 7x to the 4 times 7. So I'm just expanding this first bracket here. I'm just doing a little expanding here. Good. So follow me. 2x to the 4 times 7, that should give me 14. 14x to the 4th, right? Plus 2x to the 4th multiply, so see it like this. I'm multiplying this by this, and then I'm multiplying this by that. Simple expanding of brackets. And this here should give me what? 6x to the 5th, no, to the 6th. 6x to the 6th, right? Remember, 2 times 3, that gives me 6 here, that wacky 6 of mine there. And x to the 4th multiply by x to the x squared. Remember the rules, you keep the base, you add the power. So that's how I end up with x to the 6th. And I could multiply it on the other side here. So I have 7 times 8. 7x should give me what? 56. I hope I remember my timetables. So that's 56x to the 4th. And that will be plus x cubed times that. That will give me 8x to the 6th. Good. And from here, all we do is basically simplify. One of the things I love to do when simplifying, and I advise you to do the same, you work from the highest degree power to the lowest. So here we're looking at what could compute. the 6x to the 6 could be computed with 8x to the 6. This is positive. The 6x here is positive, and this 8 here is positive also. So when I compute those two, 6 plus 8, that gives me 14. So that will be 14x to the 6. I just add those two values. And it so happened here that the x to the 4th here can be added with the x to the 4th here, and that's the second degree, the next lowest degree. So that should give me a positive, because this 14 is positive and the 56 is positive. 14 plus 15, that should give me what? 70, if my math serves me well. So that is 70, and the x stays as it is. So this would be my answer in the lowest form. There is nothing I could do to further break down this. Well, yes, there is one thing I could do, but I would not do that. Based on what the question is asking, sometimes you could use a multiple here. For example, I know 2, I believe 2 could go into both, not believe, I know for sure, 2 could go into 14 and 70, and then the x's could be broken down by x to the 4th, and it could break down these two. But if not asked, or if not required, your answer stays, you could leave your answer just like this. So that will be our first derivative, y prime, using the product rule. And that will be our final answer here. Let's go on to number 2. Number 2, now we have a little shifting to do, but again, the concept remains the same. So here we have 1 over x squared written as a rational. So my advice to you, before you start the differentiation, I'll recommend that you invert this fraction first, write it in an easier way to see. So I would say, I ain't start differentiating yet, still f of x. So my f of x here will be equal now. I have the same thing here, but I'll just invert it. So I have x to the minus 2. Yes, multiplied by 3x to the 4th. 3x to the 4th. And that is easier. That when you put it this way, it's a lot easier to see how to go about with your product rule. So here now I have a function multiplied by another function, and thus again makes it qualified, or that what qualifies it for it to use the product rule. So now I could start differentiating. So now I have f prime of x equal now, and again I leave the first as it is. So I'll keep the first one like that, and I multiply by the first derivative of the second one, which in this case happens to be 12x to the 3rd. Again, if you're not comfortable with the power rule, just look back at the previous video. It will be in the thumbnail above there. Just check it out in case you're not sure how to apply the power rule. So here we have this, and now continuing plus. So remember, the first function stays as it is, and I find the first derivative of the other one. And for the second part now, I keep the second function as it is. So I have the second function as it is, and then I find the first derivative of the first one, which is x to the minus 2. So again, the minus 2 goes in front, and minus 2 minus 1 will give me minus 3. So that's my new power there. Good. Let me just take out these lines here. Right. And this is the end of the differentiation part. And like we did in the previous one, we can see if we could clean this up a little. So let's see here. First of all, to start my cleaning process, I will revert both the negative powers here. So this, I'll put it back to how it was initially, and I will do the same thing over here. This will help us to see something a lot easier. So with that in mind, this is the same as 1 over x squared. I'm just going back to what I had initially, and that is being multiplied by, I'll just remove the brackets so we could see the math hopefully a little easier, x cubed, and that is added to, and again I'll remove the bracket over here, so that's 3x to the 4th multiplied by minus 2 to the x cubed. Yep, that's it. And let's see if we could simplify even further. So in the first bracket here, in the first, not bracket, but the first side here, or the first part of this question here, we have 12x. So simplifying further, we have 12x. So I'll break down last, don't worry. 12x cubed all over x squared, and need some space at the top, x squared plus, on the other side here, no, not plus, sorry, not just saw the sign there, it will be minus. So this is our x here, and this will be minus because of this negative 2. So it will be minus 6x to the fourth, all divided by x cubed. And some person might look at this and say, oh my goodness, we're going to subtract and multiply now. But no, I would go even the easier route. This here can break down, the denominator here can break down with the numerator, and the denominator here can break down with the numerator. So ultimately, this would leave us with a very interesting answer. Just allow me to move this whole thing here to the top. So I'm moving this whole thing here over here. So I'm continuing over there. I hope this doesn't tie us up. So this x here could go into this x squared term times here, x times, x cubed times. Let's put it like that. So that will be 12x at the top. Minus this here could cancel into this here. So that will leave us with 6x. Wow, this worked out to be a very beautiful answer. So at the ending of the day, our f prime of x, this is our final answer here, f prime of x will actually be equal to 6x. Oh, this is sweet. I didn't see that working out so sweet. Yes, but that is our final answer there, 6x, and it worked out very well. Again, it took some working, but again, if we understand the procedure coming down the line, it's actually very straightforward. So 12x minus 6x gives us positive 6x, and that is the first derivative of f of x when using the product rule. And that brings us to the last question. Right, so that brings us to question number 3. I trust you'd have gotten the same answer for the previous one. And here again, we can see that we have a function being multiplied by a function. Therefore, we know that the product rule is applicable here. And in this one, we could go straight away into finding our derivative. So I will go into my dy dx one time. There is nothing I need to rearrange or fix back, so I jump straight into it. So my dy dx in this case would be, and again, I'll leave the first function as it is. So I have 5x plus 3x cubed, and I multiply that by the first derivative of the second function or the other function, in which case would simply give us 8x. Good. Remember, the 2 goes in front, and then I take away 1. So when the 2 multiplied by the 4, I get 8, and 2 minus 1 will give me 1, and x to the 1 is the same thing as just x. And from the previous video, we would have learned that whenever you differentiate a variable or a constant, you get 0. So there's no need to put x plus 0. And on the other side now, I leave the function, the other second function as it is. So I have 4x squared plus 8. So that's the second function. And I multiply that by the derivative of the first function. So in this case, the derivative of the first one will be x plus 9x. 9x squared. Good. And again, same thing over here. Remember, the 3 goes in front. So 3 times 3 is 9. And then 3 minus 1. That gives us 2. And this here pretty much brings us to the end of the differentiation. And here now we just exercising our algebra muscles and see how well we could nice up this result here by doing some expanding and adding and subtraction. Good. So here now I could expand the 8x. This 8x here can be expanded into this here. And again, we're going back to basic algebra. So 8 times this here, and we have the same 8 multiplied by this over here. If I do that, I will end up with 40x squared, right? So 8x times 5x is 40x squared plus 8x times 3x cubed should give me 24. So 8 times 3 is 24, and x cubed times x should give me x to the 4th. Plus, over here now I have a little quadratic kind of thingy. Remember in secondary school, high school, we learned that to expand a quadratic equation, we do the first by the first, then the first by the second. That's one way to look at it. Then the second by the first, and the second by the second. Sometimes we get caught up and we only multiply each one by each other once and then leave it at that. But no, it's everybody by everybody once. Right, so we have 4x squared times 4. That should give me what? 4x cubed. So 4x squared times 4, that's 4x cubed. Plus 4x squared times 9x squared, that should give me 36x to the 4th, right? Then I go move on to the 8 over here. 8 times x, that should give me straightforward 8x. And then I have 8 times 9. If my math serves me well, that's supposed to be 72x squared. Ooh, very lengthy equation, but simple procedure if we follow it, right? And from this point now, we just look to see what can be equated with each other and just close up and nice up our answer. So here again, we're starting from the highest degree. So here I see we have x to the 4th, and here I see we have an x to the 4th. So I could put these two terms together. So this x to the 4th and this x to the 4th, that will give me what? 36 and 24, they're both addition, they're both positive, so we add in, and that should give me what? 80, 60. So that will be 60x to the 4th. Good? Plus, I'm looking for the second highest degree now, and the second highest degree after 4 will be what? In this case, we have 2. So we have 40x squared here, and we have 72x squared here. And if we add these two again, we're supposed to get what? 112, I think. Subject to correction from my maths. 112x, we just added. So 112x squared. Plus, we have, oh no, my bad. Look at, we have a cube here. I did not see this. Look at, we have a cube here. So I will rather put the cube before this. Yes, because we're keeping the order. So I'll put my 4x cube. There's nobody else to compute with the 4x cube. So the 4x cube goes just like that. And then we could put our 112. Yes, we could put our 112x squared. Yes, keeping the highest degree. So remember, we're going from the highest degree to the lowest degree. So we have the 4, we have the 3, we have the 2, and then we just have the x. So yes, we have to color this one out too. Let me put it in black because some people might think we might be adding that to the squared term. No, that's black. Right, and then for the last one, we have our 8x in the first degree, and there's nobody else to break down that with. So the 8x goes just like that. Yes, and this is basically the answer to our given function. So it looks like a lot of work, but no, it's actually very straightforward. Once you follow the procedure, again, it will be very easy. And this is the various form in which you would always see the product rule showing up. So this will bring us to the end of today's video. So again, feel free to like, share, and subscribe. If you haven't seen the first one on the power rule, again, you could go back to it so you would see the basis of the power rule, especially when you have to differentiate a constant, a rational, and a root. That is what we addressed in that first one. Here we simply did the product rule. Again, share this with your friends. You have a good day. See you all.